Hello everybody, the HobbyKing RX 3-axis gyro with receiver has come in, and I paid $24.99 for it. This is the RX version 3 3-axis flight stabilizer from HobbyKing, based on the version 2 flight stabilizer and combined with the R615 receiver shown here. Now the R615 receiver does not have a satellite receiver port. If they had incorporated an R610 receiver shown here, they would have the satellite receiver port on the side. So that means the new version 3 3-axis system will not have a satellite port. The dip switches and gain pots will be the same on the version 3 as they are on the version 2. Now here's a side-by-side on version 1, 2, and 3. Now it's my understanding that version 1 will be discontinued and you can't order version 1 anymore. Version 2 came out with some new features. For example, it has easier to adjust gain pots, it has a remote on and off control, and V-tail and delta mode switches, which version 1 did not have. So version 1 will not be available anymore. Now as far as version 2 and version 3, I believe version 2 will continue to be around. Version 2 will stay around because it works with various radios. For example, it'll work with the DSM-2 radios from Spectrum, and also other radios, because it doesn't have a receiver built in, so you can use other receivers and connect them up and use just about any radio system, including some of the old 72 megahertz stuff. Another reason to keep version 2 around is you can use receivers with more channels than 6. You can also have satellite antennas or other longer range types of antenna systems. You can also use these extra channels to control other things, like you can bypass the gyro system altogether and go straight to your flaps channel, because normally aux 1 is used to control the gyro. So if that's tied up on a 6-channel receiver, then you would have to do some workarounds. But with an 8-channel receiver like this one, you could use, say, aux 2 to control your flaps. Version 2 also has the ability to be mounted sideways like this, because you can remap the gyros by changing the wiring from the receiver to the gyro. For example, you might switch the elevator with the rudder so you can mount it sideways. So these differences between version 2 and version 3 all stem from the fact that version 3 now has the receiver hardwired to the gyro system. Pleasantly surprising to find out that version 3 actually had a manual with it, and it was ready right away, and you can download it off the HobbyKing site. I'll put a link to that underneath the video. Although this unit is Spectrum compatible, it doesn't support DSMX, but it does support DSM-2. In case anyone asks, I've heard that this gyro system does not work well with helicopters, quadcopters, camera gimbals, but does work great with airplanes. Now the HobbyKing RX 3-axis gyro is not for the beginner pilot. You're going to need some skills to use this on your airplane. It's better for the intermediate pilot or the expert pilot. After all, there's no auto leveling, there's no heading hold, no autopilot, and no return to home. For auto leveling, HobbyKing offers the KK 2.0 board, which is about $30. But after you buy the other needed features like the receiver, BEC, and ATMEL Programmer to configure the board, it'll probably run more like $50. Now for the more advanced features, like heading hold, autopilot, or return to home, you can use such things that cost $150 to $200, like the Cyclops Storm OSD, or the Arju Pilot from Arduino. Now taking a look inside the version 3, you can see that there are some LANs where pins can be added. This is for the ATMEL programming feature. you can either add these pins or you can purchase the MCU chip clip cable, which is available from HobbyKing and shown here. Also, you can purchase the ATMEL Programmer from HobbyKing, and it looks like this. I don't know if it's available yet, but firmware may be available from RC Groups at some time in the future. Okay, this is the Gladius Streamer Cut Combat Plane, which Jim S. designed, and we're going to use this to test out the 3-axis gyro. So on the back of it, behind the leading edge of the wing, I have the 3-axis gyro system mounted so that it is upside down. Now version 3 can't be mounted sideways like version 2, but you can mount it upside down and face it the opposite direction like I have here. Normally in the manual this end should be facing forward, but by flipping some switches you can mount it this way. So to mount it this way, the only switch I had to change was the aileron switch. Okay, this plane does not have a rudder, so I'm simulating the rudder by mounting a servo over here, and I'm also simulating flaps by having a servo here. So let's start by plugging in the elevator, ailerons, and ESC leads. There's a letter S molded onto the plastic right here that tells you which row of pins is for the signal. Now the signal is either the orange wire or the white wire, depending on your manufacturer. So let's plug in the elevator channel. Now the aileron servo plugs in next to the elevator servo, and now the electronic speed control onto the throttle channel. I'm also going to plug in my simulated rudder channel and my flaps, which are going to go on aux 1. You may have noticed there's an aileron left and an aileron right. I only have one aileron servo, so I chose the left. I could also have chosen the right if it was reversed, but that can be done in the switches as well. Now you might have a plane like this, and most planes are like this. If you have two aileron servos, you'll have one facing one way and one facing the other. What this does is reverse these mechanically, so one aileron will go down while the other goes up and vice versa. So you might think that you can just go ahead and plug the wires into your left and right aileron channels on the gyro system. But because the aileron channels are reversed as well, what it does is cancel out the effect, and both of the control surfaces for the ailerons will both go up at the same time and down at the same time. And there's nothing much you can do about that except reverse one of the servos. If you can't do that, or either reverse the servo or the linkage, then the best option is to use a splitter cable like this. Plug the end of this into one of the aileron channels on the gyro, and then just connect your servos into the other end. Now I have these flags set up on the different servos. This is the flap servo, the rudder servo, the elevator servo, and the aileron servo back here. So when I move the gyro or flip certain switches, you should see things happen. For example, if I affect the yaw right here, then you can see the rudder reacting. And if I do pitch, you can see the elevator reacting. And if I do roll, you can see the aileron move back here. So that's all three axes and how they react. And there's also the flap channel, and that's controlled by the same switch that controls the gyro right here. So if I flip this switch, it affects the flaps. Now these are just the default settings on my radio. I haven't changed anything in the radio, and I hooked up a servo to the gear channel just to show you that the gear channel does work. And you might be able to put your flaps on there, and maybe with the DX8 you can even switch the switch assignments, maybe change, the gear and the flaps. Now when you turn your flaps on, you would probably want the gyro to go off for landing purposes. And then when you're taking off, you would probably want the flaps down and the gyro off. Once you get in the air, just turn the gyro on. So let's talk about the switches. The first switch is the aux control gyro switch right here. And I have this reversed so that I can control the gyro remotely. Now you notice that the flaps were an issue because the flaps over here in the aux channel operate when you switch the gyro on and off. One option you could do was just leave the gyro on all the time by not having this switch reversed, and then the flaps will still operate on the aux channel, and you'll just have to land and take off with the gyro operating. The next three switches are the rudder, elevator, and aileron, and you can reverse these as necessary depending on your aircraft. Since I had this mounted upside down underneath the wing and facing backward, I had to reverse the aileron switch. You may also have to reverse these if you have different configurations with your servos for your control surfaces. Now, when you switch one of these in reverse, you're reversing both the reaction of the gyro and also the action that you get from your radio. So if you decide to reverse the reaction from the gyro by flipping one of these, then you'll also have to reverse that particular one in your radio too. Now the next two switches are the V-tail and the delta mode switches. Now you can reverse one of these to either choose V-tail or delta. You can't reverse both. If you do, nothing will happen. You'll just get neither one. You'll just get regular action. When you do reverse these, you'll get a light that will come on and blink. Now when you power up the 3-axis gyro, you will get two lights that are on solid, one here and one down here. Now this one up here is for the receiver, and this one is for the gyro. For example, if I was to get a brownout where I lost power to the gyro and the receiver, and then turn it back on, you'll see the receiver light blinking right here. Now if I would decide to switch either the delta or the V-tail mode on, I'll do that, you'll start to see the gyro light blink down here, and it'll blink at different rates depending on which one you throw. That was the V-tail. Now if I throw the delta on, you'll see it blinks a little bit faster or a shorter duration. So that's a simple hookup. It really cuts down on the number of wires and also cuts down on the weight since you don't need both a gyro and a receiver, so I'm able to put it on a small plane like this and get away with it. What you do have to do is adjust the trims. Now what I found out with the trims is, and according to the manual, you start out with them dialed in at about 12 o'clock. That's straight up. And then you can add a little more to it as needed. Now I had them dialed up too high to begin with, and I'll show you a little video of what happened when I did that. Okay, so what I've got is, for the roll and the pitch, now like I said, I'm not using the rudder, so I have the rudder turned all the way down. But for the roll and the pitch, what I've done is I set them just a little more than 12 o'clock now, because I had them further than that, and as you saw from that last video, it went out of control. It had a lot of gyrations. Basically, it had a lot of feedback, and kept getting worse and worse until the plane just went crazy. So I turned them down, just a notch or so, so they're just above 12 o'clock high, both of these. And so now we're going to take it out and test it again. Okay, I got both cameras running now. One's on the plane and one's on my hat here. So this camera is running, and the one on the hat, this one over here is not running. It's just an old one that I got on here for balance. This is a 640 by 481, and this is the high def one, 720p. Alright, let's turn on the radio. Alright, let's plug in the plane. Alright, now got throttle. Now let's flip the gyro switch, or it's actually the flap switch. Grass is a little wet, so I might get a little water on the streamer. Alright, wind is going about the same direction. Oh yeah, it's flying much better. The throttle down. Okay, coming around. Okay, I just turned on the... Actually, that's turned off the gyro. I think. That is 0. Now, coming around, let's turn the gyro back on. Okay, gyro's on right now. So it looks like I launched with the gyro on. Is that correct? I believe it is. And it's on now. It's flying good. Alright, let's turn it back off. Now it's off. I'm seeing a little more flopping around with it off. But on a small plane like this, it may not make much difference. We'll see. And of course, it's not a lot of wind. Alright, let's turn it back on again. Oh yes, as soon as I turned it on, I saw the plane become easier to handle. Oh yeah, it's easier to handle like that. There's still a little fluttering due to the gyro adjustment, but it's certainly easier to fly. Okay, let's see if we can bring it in. Coming in low and throttling down. Looks like it's going to be a gentle landing with the gyros on, and there it is. Hopefully I caught that on the camera. Yep, so I landed with it on. See, the gyro's on right now. Let's turn it off and launch it that way. It's got a lot of water on it now, so I don't know how that's going to affect me. Okay, there it is with it off. Let's bring it around. Bring it around here, and as it goes by, I'm going to turn it on. Okay, it's on. Oh yeah. Yeah, it's flying a lot better with it on. So that's my conclusion. I think if you're a beginner, the gyro may not save you from a crash. It's going to help though, I'm not going to kid you. At least it'll eliminate one problem, and that's all the twitching around the wind might cause. And also, even with a light wind, I think it helps to keep the plane balanced. It doesn't have auto leveling, so, you know, that's not going to help. Okay, as it comes by again, let's turn it off. Here we come, and it's off. Now let's go around one time with it off. I can tell right away there's more movement with the aileron, with the wings, with the ailerons not being controlled. Okay, now I'm going to flip it back on as it comes around here. Coming by me, and it's on. There we go. Oh yeah. Oh yeah. I think I could use a little up trim. Alright, I think it's time to bring it in, but well, I tell you, I'm enjoying flying it. Throttle down. Come in for another soft landing, I hope. There we go. Well, that sure was a lot of fun flying around with this 3-axis system on my plane. Sorry this video got a little bit too long. There was just so much to cover and I couldn't get it all in. In fact, I never did cover the Delta or the V-tail setups and how to wire that up. So I'm planning on making a second video to cover that. Just leave whatever questions you have under the video and we'll have another one soon. Thanks.